Hello, my name is Abdul Hadi, and I'm gonna be talking about my project, which is linear programming approach to solve the overstocking and stockout issues in retail supply chain inventory management. So, first of all, the first slide it would be introduction to identified problems. The estimate of the global cost of inventory distortion in 2023 was estimated at US 1.77 trillion. During the same year, the retailers were estimated to spend 562 billions due to the overstock alone. A high percentage of retailer in UK of 99% said that they had lost their at least 10,000 in quarter because of unsold stock. It is almost 80% of small to medium retail businesses where excess stock comprises 38% of what owned by a business. All of this data is scraped from the internet from papers which I have given in the end in the references. So these were the were faced in 2021, 2025. But I will be using linear programming based algorithm solution uh, like the Vincent from paper Vincent 2025 used a mixed MILP model to multi-echelon retail supply chain inventory planning, leading to operational cost minimizing without deteriorating service rates. Just like that, Manoharan showed that the combination of linear programming and decision-making models maximize the use of warehouse space and has identified the ideal amount of stock to store in different situations. The models of inventory using LP allow sensitive analysis and thus assist the decision makers to experiment with the variation in demand or lead time on costs, a major aspect dealing in uncertainty. Mathematical programming inventory optimization enables a balance to be made between the holding costs and stock penalties to enhance the profitability. Now I'm going to talk about the literature review of the challenges that are posed in retail supply chains. So it was estimated that the world cost of inventory distortion was reached US 1.77 billion US dollars. Out of stocks alone cost approximately 1.2 trillion, whereas overstocks is adding up to 562 billions to the former. Losses to the retailer are costing US trillions a year due to the inventory di- discrepancies, which include misconducts or shipping errors. Poor visibility and inaccurate data are rampant as there are up to 4% loss of damaged goods on disturbing which destroy inventory accuracy. So as you can see in the chart right next to it, that there are 68.2% out of stocks, and then 31.8% are overstocks, and total 1.77 trillion loss. Now, if we're talking about the literature review in inventory optimization, we can also take as Vincent 2025 adopted a mixed integer linear programming MILP formulation of inventory planning in multiple echelon retail supply chain that did minimize the total cost through a periodic review. Then in Vasquez Nogrel in 2021, an MILP model was deployed to plan fulfillments and in-store replenishments of supermarket chains and optimize transportation and inventory choices. Joint optimization of inventory transport and warehouse space can be done using linear programming to enhance the efficiency in integrated supply chain choice. Just like on the left, you can see the chart where it is optimized through the joint optimization of inventory and transport in the warehouse. So also the sensitivity and the scenario analysis are also easily performed via LP-based linear programming based models and can assist managers to experiment on the impact of demand variations or change in lead times or cost their inventory planning results. So this is the system model design flow diagram. So my project is still in its early stages, but I would still tell you about a little bit about the project through this. So this is the optimization engine, which is the optimized engine, which optimizes the engine, so which uses MILP SPILP model, okay, which maintains the minimizes the total cost variables through shipment and inventory levels. In this way, I have also used constraint modules like capacity, budget, perishability, service level target, lead times. This would be solved in a real-time runtime. Then after this optimized engine, which uses this optimized engine uses the decision and execution this part of optimal plan, which use decision support that recommends order plan replenishment schedules which are executed by POS or push to WMS, KPI dashboards, stockouts or overstocks, costs, slays. They send an alert to the optimized engine. So these are the data inputs I'm using, like market, supplier, POS, ERP data, which then goes to the analytics and forecasting, like data injection, cleaning, ingestion, it cleans the data, then demands forecasting, and then uncertainty model goes to MILP. So that's the feedback if everything doesn't work out, it goes to the reoptimization, which is then monitored inventory counts and returns, then reoptimized on a scheduler. So I propose this development plan, and I also have the justification of the key implementation decisions. So on the right, you can see my development plan. First, build MILP mixed integer linear programming model. Then implement stochastic integer linear programming formulation, and then I would improve the runtime, and then integrate into ERP, which is enterprise resource planning, then which with decision support platform. So to optimize the cost, MILP will be used. That model will be constructed and implemented using the periodic review. So the uncertainty in demand and cost will be addressed by using the SPLIP formulation and warm startups, heuristics, and solver processing will be used to better the computation runtime by 15 to 50% as used successfully. And to also ensure the scalability, the system will be embedded into ERP or decision supported system. All of that brings us to this conclusion that the linear programming framework offers a scalable and systematic model of minimizing retail's overstocking and stockouts. The connectivity to ERP or WMS systems will allow automated real-time inventory decisions making, or and model reliability will be enhanced by pilot testing, analysis, scenario and parameters tuning. The next stage would be the multi-echelon optimization, dynamic pricing, and forecasting by simulation through simulation. So these would be the so these are the references of these are the links and everything for the data I've scraped from the internet. I've been working on this for a while, but it's not complete. It's still in its early ages. So thank you for listening to me. Thank you and have a nice day.